Can y'all hear me? Alright, can y'all hear me? I'll put it everywhere else on Odyssey, Twitch, Rumble, etc. Alright, anyways, we're gonna power through the Aether theory, keep going because I learn a lot and so on. And then also go over put this everywhere. Let's go, this is on Rumble. Okay, putting all these chats everywhere. Alright, anyways, and let's see if this should open up the chat, see how this sounds. Hey. Okay, anyways, it should be working fine. Okay, it is recording, everything's fine. I open up the chat window on X. Alright, anyways, so we're gonna go straight into it, yeah. And initially, actually, before we go into it, I have some stuff opened up. See, I had some comments on Telegram. So one's pretty interesting is it's apparently germ warfare battleground or whatever on Telegram has 25,000 subscribers, and he has like he's part of the UK column, is a big alt media following. It's like the South African Joe Rogan. Now he has Simon Shack on the show. Unbelievable. So Simon Shack is the disinfo agent extraordinaire, pushing CGI, 9/11, all that jazz. And then Simon Shack also, now he's apparently a pioneering cosmologist and trying to argue some sort of weird weird shaped universe thingy. Anyways, it's pretty absolutely ridiculous. Also, another thing I wanted to go, yeah, this is a good photo. This is from the moon landing stuff again. If you haven't seen my other videos, it's like you have to realize if you don't believe the moon landing, that's fine. But if you push the obvious, the mainstream alt media, which is completely another elite bogus, like Bartzbell and all that, like this is three different. This is a photo from overhead, a photo, high definition photo here, and this is live TV coverage, all matching up, exact same thing. So it's like, it's pretty next level. Anyways, I want to go over this thingy quickly, just because I got tagged here, and then I'll go to it. This person is about the moon landing. This right here, he tagged me, says. This is sus. What do you reckon? Also, have you seen the bloopers from blooper reels from ISS? There's some doozies in it: wires, harnesses, green screens, glitches. Yeah, you gotta be very careful. And this is the one that he shared. This one. I'll play it.
So you can
I'll go this
fix
one.
it around cables, and so you need.
What people don't realize is it stops floating around. Even if you have something dropping, that doesn't mean that this stuff's not floating around. So it's just if you actually, yeah. But I think there's I think there's something actually dropping.
All these things to keep your stuff in
So
place.
I just want to go over. I want to go to this one. I want to fact check this one here. This is the one that people. I've seen this before. I think it doesn't actually drop. I thought there was one without the noise. Here, this one here.
All these things to keep your stuff in place. You look fall down.
Yeah, this one here. Nothing actually drops, actually.
There you go. He's looking for, he's searching for it.
Alright, it was a noise, but it's like, but I want to see the full one, because I think I've seen the full one before. Nothing actually drops. I just want to see this thingy here. What's his, name here? I'll do a reverse search. Actually, I'll play this, and then I'll get into this nitty-gritty.
He's looking for, he's searching for it.
Okay, there it is.
There you go.
It's like these little one clip things. It's basically it's people don't realize this. If that is actually like something, if something actually dropped as it shouldn't be, it doesn't disprove that they're literally floating around. So that's more, that's bigger. That'd be an argument that they have an anti-gravity like shield, and all of a sudden it was some interference and didn't have some anti-gravity part there. Anyways, can I quickly here, and then we'll go straight into this. Google, or because I just want to see the original. I hate when they don't show the original and then just talk over like stuff. Visual, yeah, this one here. This one here. There's again, all the flat earther guys push this same thing. I just want to see the full thing. What's his name? Okay, this one. Yeah, okay, this is Screw Loose. This is a video here. And here's the full. I think this should be full link.
G'day everybody, where's Wally here? Well, Brandon and his crew, they went looking at the ISS today. Him and his crew, they think they're on a winner yet again.
Over the Himalaya mountains at the time.
Die wordt weer gebruikt om weer... Hier is alle apparatuur.
Let's see the full thing. Wait, I just want to see.
Himalaya mountains at the time. Man.
And we won't stop until Andreas puts the cover back. The original, and we won't stop. And
Yeah, yeah.
now let's play the original.
And there's the 35 at 3526 mod.
And we won't stop until Andreas puts the cover back.
Hier achter deze panelen wordt de urine opgevangen. En even Oké.
Yeah, so there's no screw.
Zo. Ja, dat gaan we doen. Deze maar even vastmaken. Opgevangen wordt drinkwater.
But they didn't stop and observe with a clear mind. Now let's look again, and I want to show you at 36. They wanted to bring a pile of excuses, but this time all we need to do is to point out what he missed. No excuses needed. They were all so blind because they wanted to hear and see something, but they didn't stop and observe with a clear mind. Now let's look again, and I want to show you at 36:10 in the original, just a mere 35 seconds after the sound, the D-linked bolt's still there in the top right of the cover. Oopsies.
Oh, the
How
bolt.
about that? How about the top still there? Sound. The D-linked bolt's still there in the top right of the cover. Ooh, the cover. Down 35 seconds after the sound, the D-linked bolt's
I think it's this part here. So.
still there in the top right of the cover.
Yeah, it is. Okay.
Oopsies. How about that? And that's before they get into the whole claims of editing and so forth. That's all that's needed to debunk this. But I think I will keep adding some cuts because there's, well,
Gebruikt. Hierboven. Denk hierboven.
Yeah, this is nothing actually drops. So I'll send this one here. Yeah, I'm gonna I'll show this one here at 208. I'll just say at 208. Yeah. Okay. I'll send this one to this guy. I'll say here. I've seen that before. Nothing actually drops. It just opens up the hatch. Here is the extended cut. Okay, let's do this one, and then here's a full tour. The full 1.hour video. Even if something magically fell, would suggest they were using advanced anti-gravity. Let's say advanced anti-gravity. Let's say projection, but had had random interference. Interference zones of normal gravity. This is far-fetched, but more believable than the flat Earth claims. Than the flat Earth fakery claims. I've seen that before at the end. I okay. Yeah. So, anyways, it's like there's literally none of these. Where's this guy? I have seen a lot, but every single one that I examined closely revealed nothing special. Just all media disinfo, disinfo flat earthers. Okay, yeah. Anyways, that's that. We have power through. What else we have in the docket is this a scammer. Okay, we got this scammer delete, proceed ban, and so on. All right. Anyways, I'm gonna go. Someone in the email before fundamentals. This one is comments on Aether. Yeah, this guy here, guys. This guy was on his Twitch last time. I just wanted to see if I could reply to him. This was a math question he wrote. He said maths. He just has a ginormous, okay, 11 pages, but what's the actual thingy here? And then this is Anos. Math questions paper. Okay. I'll just say, which question do you need? Which question do you need help with? All right. Anyways, that's that part. And now I'm gonna, yeah, that was just this guy's pretty good there. I'll subscribe this flat earther, anti-flat earther debunking mumbo jumbo. Yeah, yeah. There's an audible click. Okay, yeah. There's a click. Nothing actually falls. Yeah. Anyways, this is a pretty cool.
En spullen voor robot.
It's like they're literally floating around. Like it's. They're, I don't know how anyone can look at this. They're literally floating around. How could anybody look at this and say, "Hey, there's some sort of CGI or whatnot"? They're literally floating. Are they in water? Or like, what are they doing? How are they doing this? Is there wires? Wires for an hour and 10 minutes? Like, are you guys insane? Um, like he's literally floating. Where's the wire? How's the wire going through? Is the wire changing in like 3 dimensions or something? It's got a wire. Where's the wire? On here, and then all of a sudden it goes through this part. He goes through a little loop there. All right. Yeah. So that's absolutely wild there. All right. Okay. Yeah. So, anyways, that's that part. Yeah. It's like, how can anybody? Yeah. So that's that. Let's see if he. The scenes were taken at the same time. Wait, the scenes were used what appears to be shirts being pulled by something do look interesting. Okay, have you analyzed photos for consistencies? This guy, uh, I'm suggesting they are consistent. So any fakery would have to be consistent. AKA increase of complexity. Yeah, it makes fakery harder. Yeah, anyways, I'll say not yet. So yes, anyways, being consistent, yeah, I don't know how this guy Steven F could keep going on and on about this. Anyways, I really don't care, like this nonsense. It's like, especially once I show that Bart Spell's a liar. And yeah, that's just. Anyways, oh yeah, here's the threadcast, guys. I'll be posting stuff in here as I go on. Live chat. Okay, I'm gonna post this here as well. And anyways, I know I'm gonna power through. It's actually good. Thought a lot of comments in here because I can sit and do it. Oh, let's just go back to Dinu part. This one is the email here. Maths. Okay, I replied to him. Nothing happened there. Okay. Let's go here. Let's just put a thingy there. Okay, I'm getting peeps in here. I'll be back. I was muted. Oh, sorry, I was muted. Okay, so I'm Gary Jacks. I'm back. I'm back on. Okay, I'm back on. Anyways, I was just chatting, guys. Sorry about that. I had muted when I had to. My nieces were at my door like slamming. I had to go and tell them off. Okay, anyways, I'm back. Can you all hear me? Hi, Gary. Epic stuff. And I think the book should be arriving soon. So great that you had them on the school library and all that. So, anyways, I'm gonna go back to this fundamental theory of ether. I'm telling y'all this is the big deal. Okay, so now. Last week we ended off, I ended off here when I sent him an email. So I sent email to Ionel Dinu, and I sent right here, said, hi, Ionel, I just added your updates. Note that I think you made a typo, see screenshot below right here. this attraction between a body negatively charged and one uncharged. This part right here, excess quantity of vibrating electrogen. This should be A, not B. On here, this is excess, so that's going to be very, very negative. And then it, excess very negative, and then and then it goes over here. It connects to this one here that's not vibrating, and it's just normal amount. And the reason it's not vibrating, again, that's why to get static electricity, you need to shake things together. So you need to actually vibrate that electrogen, and that's creating that attraction through the ether, basically coupled like a metronome. Okay, so also, can you explain the part a bit, the part below a bit more, possibly with a diagram? This was the one I read over earlier. So I said an even stronger argument for the idea that the origin of waves emitted by a radio antenna is not the high frequency electric current surging in the antenna. Is the experimental it's basically another reason that it's not the radio. Basically an even stronger argument that the idea that the origin waves get 21 centimeter flipped spin. All right. Big stuff. Anyways, not sure what that means. So an even stronger argument for the idea that the origin of the waves emitted by a radio antenna is not the high frequency electric current surging in the antenna. So basically, the origin is not the current, is the experimental observation that a closed oscillating circuit does not radiate if the current of high electricity, high frequency flowing in it is such that the diagram flows in all its directions at the same direction at the same time. The current flows in all its parts in the same direction at the same time, while the same circuit does not radiate radio waves into the ether while the same circuit does radiate into the ether if the current is made to flow in opposite directions at the same time in different parts of the circuit, and thus creating loops, antinodes of potential along the wire. So basically he's saying circuits don't radiate if there's high frequency, but then it's high frequency though in such that the current flows in all parts at the same time in the same direction. So I think what it means is if you have a current like this, if you have a circuit and there's current goes through all of it, and then another one comes through all of it, you're not going to have radio waves. So high frequency flowing in such that the current flows in all parts in the same direction at the same time, while the same circuit does not. Yeah, but then the same circuit would if you just go forward and back. Yeah, this is so I think that's what it means. If the current is made to flow in opposite directions at the same time in different parts of the circuit, thus creating loops, antinodes of that. So this is saying as long as in the circuit you have some that is going opposite. Yeah, I need to see a diagram. So it turns out that therefore that it is critical for the emission of radio waves to obtain pulsating antinodes of potential in the antenna. And since the pulsating antinodes of potential are created by pulsating electric charges, electrogen, and these impinge on the ether periodically, it follows that radio waves thus created must necessarily be longitudinal waves of compression and rarefaction of ether, in which the pulsating electric charges act on the ether just like vibrating cone of a loudspeaker acts periodically on the air around it and produces sound waves. All right, so this is the part I said. Can you explain a bit more? Another question is about the radiation pattern, and was wondering, what about the vertical direction? Wouldn't radio waves push outward to space too, or is this diagram just looking at ground receiving patterns? Again, this is from an actual department of the army. It's the army. It's not him making this diagram. It's the army. So I said, so I said, what about the vertical direction? Wouldn't radio waves push outward to space too, or is this diagram just looking at ground receiving patterns? And I assume that the gap in the center of the pattern is due to the high electrogen voltage accumulation. And see how this is spreading across. So this is the current. Basically, this is the antenna. It goes back and forth, and then the radiation pattern. It looks like this, which is quite interesting. Again, it's from the army. So it's like, it looks like it's being pushed outwards from that zone there. Radiation pattern produced by a quarter wave antenna. All right, and again, when the voltage is highest, that's at the tip, and when current is a minimum, looks like it's being pushed out. So that's what I sent there, and I said I've added, and there's another part from he argued, from a screenshot I was asking for clarification. I said I added more such wavefronts in the original figure on the previous page left, or below, and I obtained the figure at the right where it can be seen the direction of the propagation of the waves emitted by this antenna is indeed downwards from its tip. So basically, he's saying that if it's pushing like this is I've added more wavefronts. So he's saying the wavefronts are going to be like this. That's the voltage matching up basically high compression over here, and then rarefaction. So think of voltage as basically like compressing the electrogen or electricity or electrons into one little area. So basically high potential, high charge. And then that pushes everything outward. So it's high charge, but the current's low because it's not flowing. It's just all accumulating there. And then the wavefront, he said, will look like this and push downwards like that. Okay, that's interesting. That's an interesting setup. Any clarity would be much appreciated. All right, so I sent him that. And then he replied here. So it says, fundaments of a theory of ether, part 4. So, hi, Matthew. Thanks for the notification about the typo. I've corrected it. I've sent you 3 screenshots, which contain some diagrams from Fleming's book I reference at V3. So he references actual Fleming's diagram. And what I'm going to do is actually, I think he sent the actual PDF. Yeah, so he sent a PDF, and I have this right here. So I'm gonna go right here. I might have to just look at this before that I do the streams, dive into this, and then when I do the streams, I go full on. But because the thing is, this forces me on this. So I'll send you 3 screenshots which contain some diagrams from Fleming's book I referenced at V3. The screenshots 002C says exactly what I wrote in my article about radiation and non-radiative closed oscillating circuit. You can produce along the same wire, straight or loop, electric currents that flow in opposite directions if you use an alternating power supply of high frequency. Okay, so basically saying you need electricity going forward and backward. Has to go in opposite directions in that same circuit. At low frequencies, your current is in the same direction all along the wire, and then reverses due to reverse of the polarity of the power supply. But if the power supply switches polarity much faster, the charges along the wire do not have time to switch direction, and you end up with currents that flow along the wire in different directions at the same time. The ones, so this is interesting. At low frequencies, your current is in the same direction all along the wire, and then reverses. So it goes there and then reverses. But if the power supply switches polarity much faster, the charges move along the wire, do not have time to switch direction, and you end up with currents that flow in the same direction, in the same wire in different directions at the same time. But how do you have different... Okay, oh yeah, because if you have some going backwards, some forward. If you don't have time to switch direction, then you end up with the currents that flow along the same wire in different directions at the same time. The ones that flowed in the previous direction and the ones produced next to them by the power supply that has switched to opposite polarity. It is like sloshing water in a tank so fast that the water does not have time to flow from end to end, and you produce water waves. If these waves are a very high frequency, then they can set the air above them in vibration and can produce sound propagating wave vertically, perpendicular to the water surface. In the case of the wire, these waves are due to the accumulation of electrogen on its surface and then push on the surrounding ether and create radio waves. In the paper I reference to these waves, in the paper I referred to these waves as being produced similar to a loudspeaker. The vibrating cone of the loudspeaker pushes on the air, while the vibrating electrogen on the wire pushes antenna on the ether. So again, this is, but the thing I'm trying to wrap my head around is because you have a wire. This one is a speaker, literally actually pushing back and forth, but the wire is going side to side. So like, what's the so what's the actual wire doing? Regarding radiation in vertical direction, radiation in this direction will be produced by electrogen literally piling on the surface of the tip of the antenna, and this surface should be facing straight upwards, which is rarely the case since antennas are usually terminated in a sharp cone. So yes, there is accumulating and pulsating electrogen also on the surface of the tip, and this also produces radio waves, but very weak compared to those due to accumulation of the electrogen on the lateral surface of the wire near the tip. So radiation from the tip in the vertical direction lengthwise is not very strong, and I suspect it can be detected only at very small distances from the antenna in the so-called near field. The radiation pattern with the gap in the center is measured far away from the antenna in the so-called far field, where only very strong waves reach. So the radiation pattern with the gap in the center is measured far away from the antenna in the so-called far field, where only very strong... so basically, they're only obtaining the far field one, so the near fields are not getting much. Okay, they're getting some bunch of messages. All right, so radiation is much stronger from the lateral surface of the antenna, and therefore waves leave the antenna in perpendicular direction to the antenna, a bit slanted actually, as I've shown with the colored wavefronts, because on the surface towards the tip, electrogen can pile up in a greater quantity, so it can push the ether more powerfully than on the surface of than on the surface of the tip. So basically, because on the surface towards the tip, electrogen can pile up greater quantities, so it can push the ether more powerfully than on the surface of the tip. Oh, then basically, on the surface getting close to the tip. It is conceivable that accumulation of electrogen on the lateral surface would also produce radiation in the vertical direction, but I suspect that again it is very weak, detectable only in the near field, not in the far field where this pattern was measured. All right, and he took screenshots here. This is from page 277. He highlighted this part right here. I'm gonna go over here, and then it's basically he sent me the book. This is the Fleming's one. Again, if you go here, V3. So if you go to reference V3, and I'll do a home. Okay, and also we have someone in the chat in here. All right, we have Odyssey. Okay, Epic Stuff. Can you all hear me? Epic Stuff there. With a thumbs up. Uncle Murray's in the house, and so on. All right, I think we had some yeah, comments here. This guy says, as you know, my connection is a video footage was shot with human beings on a soundstage, with a few exceptions, whereas the still photos were taken using miniatures. This is a revisionist stance. Photo 1 is therefore with actors. Photo 2 would be a miniature. There are absolute similarities in images, like the path of the footsteps to the left of the aldrin, thing which curls around. But look at the shadows, in the particular shadow of the flag and the astronauts are parallel to photo 1, but are perfectly like yes, it's again yeah, so anyways, yeah. It's like I don't know, I can't take this seriously. Uh this miniature one. There's like you think like these are miniature photos. It's like high definition footprints, or they got like miniature footprints. It's perpendicular parallel wait, where did he say that's this one goes like that. Again, it's all just perspective. There's that one there. Anyways, why does he reply in the wrong one? Anyways, as you know, using miniatures, one photo soundstage, photo 1 is therefore with actors, photo 2 would be a miniature. Photo 2, how is photo 2 a miniature? There are absolutely similarities in the images, like the path, footsteps. But look at the shadows. In the particular shadow, the flag and the astronaut are parallel in photo 1, but are perpendicular in photo 2. So parallel in photo 1. These are not parallel. These are curving inwards. This is the flag. This is literally the lights over there, and it's like yeah, it's almost parallel. It's pretty close to parallel. And then photo 2. Okay, photo 2. Where's the you can't even see the shadow of this one. It's slightly over there. So I can't even see that shadow there. It's hiding right behind him. All right, this is his, and then this one's very hard to see. So where's the shadow on this one? It looks like it's probably behind this thing. There's no shadow of the this one here. It's very hard to see. It's like perfectly flat. And this one has no shadow there. So the question is, well, why can't you see the shadow? All right. So there's a shadow thingy, but it's like yeah, well, but a perpendicular in photo 2. There's no the flag, shadow flag, and astronaut. There's no, you can't even see the flag, the shadow of the flag. How is it perpendicular? You can't even see it. You literally can't even see the flag shadow. Where's the shadow? Somewhere over there. Yeah, so that's a weird anomaly, or I just didn't see it properly. Anyway, so the shadow's not even there, or just the photo 2. This one's hard to see that as well. That's interesting. This one you see it there, but it's like literally matches up with this guy here. So all of you have is just literally just a little increased elevation. You won't be able to see it. Anyways, this is a thin line, so you won't be able to see. Yeah, it looks like it's a bit higher elevation. I'll say photo 2. Yeah, there's a line right here. No, there it is. I see it. Where's the perpendicular? No, it's not perpendicular. Yeah, so anyways, I don't know what's going on here. Photo 2 has the how do I draw on this? I can't even draw. Like, what is going on here? I'm gonna do something magical. I'm gonna do this. Screenshot big. Oh, there's a drawing one. Yeah, so this right here. There's a drawing thingy. Yeah. Okay. Yeah, I'll just say save. Photo 2 has the shadow of the flag also parallel, not perpendicular. Yeah, the shadow of the flag and astronaut, but look at the shadows in particular. It's like that's literally the spot. Yeah. So that was so basically these match up perfectly. Yeah, this matches up perfectly. That's the shadow is right there. This other thing is in the way. So the question is, that's not a shadow. This is a shadow of the this is a shadow of the sand there. And there is the yeah. There's a line there. That's actually yeah. It's literally yeah. So it's photo 2 has a parallel. So we conclude it's parallel. There it is. So why is he talking about perpendicular? This is literally just sand. This is such good detail, unbelievable. Yeah, there's the actual thin line of this part, and then there's gonna be yeah, and there's yeah. So notice a super thin line, and then you have the big one there. So the big one's not even in that photo. Anyways, so we just proved the moon landing. This is actually irrefutable proof. Um, all right. Anyways, so we just solved the moon landing. Yeah. So anyways, keep going. That I know. I think I'm getting the picture. I'm gonna have to. Yeah. So next time I won't be reading that. I'll try to understand his email before I go over it in live, just because it's just I need to get get through this fast. I don't want to waste so much time. So why is the flag waving? It's not waving. It never waves. Yeah, it's not waving. I have the full thing again. It's like everybody just says things without actually looking. There's a it's a photo. It's not a waving. Here, I'll show you what I mean. I have the full this one here. I'm gonna go to just quickly. That's Apollo 11. And I have one here. Rare. Yeah, this full moonwalk original. If you look at it like 100,000 times speed, there's nothing waving. Okay, once they put the flag on there, it's like literally not waving. Go play to 1000x speed. Yeah, nothing's waving. Yeah, the flag's not waving at all. It's not waving. It has like supports to make it horizontal. Watch the full video, nothing waves for hours. Yeah, so there's nothing. It's not waving. It's literally just not waving. There's literally it's just like if you have any vibration though, you'll shake it. But there's no waving. Yeah, there's literally no waving at all. It's completely the exact same thing for the entire time. It's like, yeah, once they add it, and it's like it's crumpled up, but it's not waving. So they add the thing in, and it never waves the entire time. So it's like once it stops shaking, now it's stuck forever. Yeah, and there's no waving. It's just perfectly still. And that's one that they took. And there's another part here. I think in the 2 hour mark. I think Neil Armstrong or whatever jumps so high on in like one jump goes like 6 feet in the air or something. So right here, this is when he goes back on the ladder. It is undulated. It is crumpled up. Yeah, it's crumpled up after they took it out of the, yeah, like out of the bag package or whatever. Yeah. Which was I think initially vacuum sealed. Yes, anyways, it's just initially vacuum sealed, but I want to go to the jump quickly, and then we'll go back to the Ionel Dinu. But again, that one I'll have to try to power through because I'm working on the spherical harmonics math video. It's taking a while. There, I think he jumps in here. Yeah, there it is. This is one of them. He jumps super high for some reason. Okay, I think he no, yeah, he gets there soon. Okay, no, I'm gonna go over here. Okay, this one, yeah, there's a one he jumps. Okay, this one right here. That's like oh yeah, let's go back here. So if you watch him here, look at his foot. I'm gonna play, and he just one jump, 1 foot. Ready, and he's like trying to jump. Okay, and then he jumps right there, right? Yeah, unbelievable. Yeah, he literally jumps like 5 meters. Oh, we have Wild Swigger, or the like the Jamie Bartlett who went off the deep end with the like alt media nonsense about moonlighting. But anyways, howdy. Yeah, so the moonlighting stuff. I'm just going over some comments in here. There's some people are sharing some obviously disinfo stuff. Yeah, it's like people can't get it, except the fact that there's no easily verifiable fakery of the moon landing at all in any way. Even the ISS footage, there's not a single one. Like I went here for those just showing up. I showed this says there's a screw dropping the ISS. I'm like, no, it's not. It's just everything's just fake. I mean the flat Earth nonsense all just fake. Anyways, let's go back into the Ionel Dinu setup here. Yeah. So anyways, I'll be trying to go understand this more So he sent me this one here, and it sends me some more stuff here. So I'm gonna keep going. So this is diagrams he sent. Stationary oscillations in a looped antenna. This is page 277 on theirs, and then I'm gonna go to 277. Anyways, these Wednesday live streams are for grabbing. This is 270. Where's 277? Oh no, 277 of this thing. Okay. Oh, those are the they're highlighted by themselves. Interesting. I thought it was his highlighting. So anyways, let's go back to this part here. So the thing where I'm currently at is, let's make this bigger, just whatever. Are you muted? I'm not muted. Can you hear me? I should be able to hear me. No, I was muted earlier. I think you're just watching this live. You're watching it delayed. Was muted earlier. Okay, this is just delete the spammer. Ban and yes, okay. Yeah, so I was there. How do I just ban these people? Okay, this guy's banned. Okay, so I banned this guy on Twitch, just putting spam links. Twitch has a lot of spam. Like, anyways, I'm gonna go back to Ionel Dinu setup here. I'm gonna go and then follow through exactly what we had issues with. Basically, just trying to understand it, and then I'll try to do this behind the scenes instead of doing it all live here because okay, this part right here. Okay, what is this guy talking about? It's like he just crumbled the bag up. What would happen to a vacuum sealed bag trying to be opened in a vacuum environment? Yeah, it just crumpled up. I mean, it's just super crumpled. Yeah, because it has to be compact. Yeah, anyways, it's just crumpled. It's just like just try it yourself. It's gonna be super crumpled. It's just super crumpled. Yeah, and again, there's no waving in the entire thingy. So the guy's saying is you can watch 2 hours of it. There's no waving. If it's like, yeah, again, if it is a video faker, yeah, but there's no waving. So what I'm trying to say is whatever this image is coming from, There's no waving of this flag in any way for hours. All right, so whatever that is, it's not waving, and you can see it crumpled out. You can see them. You can see them. I'll just set it right here. I'll just send it to him. You can see them putting it together here. You can see them. You can see them take it out here. Plus, in other Apollo missions, the same thing shows up. The flag appears the same. And you can see my trailer, trailers. Right here, if you see the trailer, they take out the, or did I fast forward it? But they take it out. Oh, I didn't show it. Yeah, this one right here, it's the same thing. They just take it out. So here it is. He just takes out the thingy. And there it is. You can see it's a clear look taken out. Okay, you can see a clearer look. Let's see a clearer look of the flag. The what's it called? It's like I don't understand, like, why do people focus on like literally minute details that just like there's nothing special. Yes, I think nothing happens. Nothing happens special. Yeah, it's like I have a vacuum chamber, nothing happens. Probably less spectacular than there. Okay, anyways, Tammy's in the house. Yeah, no worries. Yeah, you can see them, yeah, plus another, a clear look. Anyways, clearly look, clear look. Alright, again, yeah, so remember, these Wednesday streams are for any science, math-related questions, and moon landing is science-related, etc. I'm gonna start standing and continue on the journey. Alrighty. Okay, so yeah, I'm gonna go straight into this part. Okay, so this is where I wanted to solve this. This is the part I wanted to solve fully. Okay. Thus at the origin, well, the maximum current is below. If the current height doesn't tend to be unimportant. See where I ended up at. Here, reflected wave. Okay, this is the part where, yeah, this antenna radiation pattern. Emission to radiation is at right angles to the emission. This is the part I just need to wrap my head around. So I'll have to wrap my head around that one. Go back to this part here. Yeah, so I should do this more. This is page 277. Anyways, let's go to 277. Where in the world's 277? Okay. Yeah, so I'll try to do this, yeah, 277. Did you get, oh no, I got the wrong, did I get the wrong PDF? Please don't time me out today, I'll behave. Is that stupid 7648? Which one's this? I don't remember you. And yeah, again, like, I have to realize, like, I just want to see evidence. I don't like opinions. Like, I literally don't care about opinions. Just give me something. Something to, write home about. Yeah, so what is he getting this from? Stationary electric waves on wires. Okay, so that's not it. Oh, there it is. There it is. Okay, there it is. So this is the part where I want to understand. Okay, this is the part I'm gonna have to just pause everything I was doing until I understand this sentence that I asked him about here. Okay, this is the part where it's like people have to put it in systematic. Okay, Why is it not showing? Okay, this is well, and the thing is, I emailed him and then he replies with a new email. Like I just don't like stuff. Okay, anyways, so this is the things I asked him. An even stronger argument. Okay, I'm gonna go over that. And this is Fleming v3. Okay, that's the paper he has, Fleming 3.3, Principles of Electric Wave Telegraphy. Okay, so I'm gonna go an even stronger argument. I need to grasp this. I don't know, even if you guys haven't followed along or not. And an even stronger argument. Okay, this is the part I need to understand. And then he says, so basically an even stronger argument for the idea that at the origin of the waves emitted by a radio antenna is not the high frequency electric current surging in the antenna, is the experimental observation that V3, this one right here, a closed oscillating circuit does not radiate if the current of high frequency flowing in it is in such that the current flows in all parts in the same direction at the same time, while the same current circuit does not radiate radio waves into the ether if the current is made to flow in opposite directions. Oh no, it does. So basically saying if it all moves in the same direction at the same time, it doesn't. But the only time is if you have in the circuit stuff going in opposite directions at the same time in different parts of the circuit, thus creating loops, anti-loops along the wires of the circuit. So I think what that means is, yeah, you're literally creating some areas on the side of the wire that has lots of electrogen and then one without. So in other words, compression and decompression. So in a way, it is like it's like a speaker, but like quite a magical speaker. Okay, so that's pretty interesting. That's what it says right here. Yeah. Anyways, that's crumpled up stuff there. All right, so I'm gonna open up the other. This is my email, and then the Dinu one. So the cool thing is, yeah, we have like contact with pretty much someone who's thought out a lot about this. Okay, so that's and then he pulled a John Hutchinson, which is a forward email. So I sent him one, then he replies over here. So so he said, I sent you three screenshots which contain some diagrams from Fleming's book referenced there. The screenshot 002C says exactly what I wrote in my article about radiative and non-radiative close oscillating circuit. All right, so that's this one right here. Figure, what did he say? 002C. Okay, what is 002C? You mean okay, I'm gonna go sufficiently long. Okay, I'm gonna read this part right here. Okay, so I think it's this one right here. So this is a looped antenna. So stationary oscillations on looped antenna. So here's a looped antenna. A very interesting case of stationary oscillations on wires arises when we consider those which can be produced on a closed and sufficiently long loop of wire. So this is a closed one, looped antenna. So and basically, let's say you have a super long wire. There's a capacitor. I think that's your energy supply or whatnot, or whatever that is. And then this is yeah, very interesting case of stationary oscillations on wires arise when we consider those which can be produced on a closed and sufficiently long loop of wire. Let a loop of wire be formed erected by two insulated vertical wires. So there's a loop there's two parallel to each other and joining together at the top. Yeah, and then he says, in one branch, let a condenser be inserted, and the other in a pair of spark gaps. Okay, anyways, he says a whole bunch of stuff here. This part I need to wrap my head around. Okay, there is a game in Scouts, triangulation, radio, hide and seek. Learn about direction, antenna design. You know, yeah, definitely. That's some fascinating stuff. Yeah, I'm just looking at more of the theoretical side here. Therefore, it is therefore an antinode or loop potential just above the terminal. Okay, so what's the second page? He says the first set of harmonics, which include the fundamental, is non-radiative and is for the whole length. Loop is an integer multiple. The second of harmonics radiative and those whole length odd integer. Okay, this, and then he references if a closed. So if a closed oscillatory circuit is formed consisting of a condenser, loop of wire, and a spark gap. We may set up oscillations in it, but by connecting the spark gaps to an induction coil. We have in this case, however, no radiation if the length of the loop compared with its fundamental wavelength is such that the current is at all points in the same direction at the same time. Slaby and Arco found that if the loop is constructed with unequal inductance on its two sides and connected to the earth at one point, then harmonic oscillations can be set up in such a way that there is a node of potential at the earth end and an antinode or loop at the other end. In this case acts as if it were two simple Marconi aerials. I'm going to go to if a closed circuit, if a closed oscillatory circuit, and closed os. Oh, and it's highlight. Oh, he highlighted. Okay, so yeah, I think. Oh yeah, this is highlighted by actual Ionel Dinu. So what I'm gonna do is actually I'm gonna go right here. I'm gonna just ask AI. Yeah. Yeah, an even stronger argument. Merita is that a closed. Well, okay. I'm gonna just ask Rock AI quickly. Explain this. What this means in simple terms. Perhaps by a diagram. Okay, and then this is a close. I'm gonna make it auto. This is a good thing about AI. They can answer stuff. All right, is auto. Okay, I'm gonna ask Leo AI as well. Ask Leo. Explain what this means in simple terms. Okay, let's see the AI of this. What in the world's going on here? Oh, actually, he says Aether. I just want to make it in a more neutral setup here. Just using this. It comes with unequal inductance on two sides and connected to the earth. So basically, you don't get a radio if a closed oscillatory circuit is formed by consisting of a condenser loop of wire. We set up oscillations in it by connecting the spark balls to an induction coil. We have in this case, however, no radiation of the length of the loop compared with its fundamental wavelength, such as the current is in at all points in the same direction at the same time. So basically, if the current, yeah, basically if you have a long enough, yeah, you're not gonna have enough vibrating mumbo jumbos. Okay, I think I pretty much grasped it, some of it. This is still frozen. I'm gonna go right here quickly. A looped high-frequency wire circuit stays silent, no radiation if current flows uniformly everywhere in the circuit like a steady pulse chasing around it. But it broadcasts radio waves if reversed directions in different sections at the same instant, forming hotspots, antinodes, or voltage built up along the wire. Okay, I'm getting a knock just 1 second. Alright, I'm back. My niece was wild and she wanted the basketball hoop thing. Okay, anyways. So in a looped high-frequency wire circuit stays silent, no radiation if current flows uniformly in the same direction simultaneously like a steady pulse chasing itself around. But it broadcasts radio waves. I'm gonna go, yeah, I think I just want to see this though. I just want to see an image. Like, why is no one making an image of something that's what I think is monumental? I'm gonna, oh my goodness. Why is it Brave search? Let's use pre-search. Okay. And this one, I just want to understand this part. Like this is kind of how it works. Like I can't. change topic. I can't like change to another thing. Okay. Let's close this high frequency. Silent loop. Okay, okay, that's a silent loop. Broadcasting loop. Standing waves, hotspots. A standing wave. Okay, this is what I wanted. Some like what is the actual mainstream term of this? A silent loop, uniform current, a loop with a uniform current, constant DC current, or a traveling wave of constant amplitude does not radiate efficiently if it is small relative to the wavelength circumference. It creates a magnetic field, but minimal changing electric field, making it a poor antenna. So basically, if you have minimal changing electric field, you don't get get that. You don't get an actual antenna. A truly uniform, steady pulsating around a loop with negligible capacitance causes also negligible charge accumulation, thus minimal electric dipole radiation. Okay, so I'm gonna go with the silent loop. YouTube. Okay, my brother's calling. 1 second. Why is he? Okay, I'm back. Silent loop. So that's pretty okay. So basically, if you have a silent loop, I'm gonna see if there's an image of it. Silent loop antenna. Current maxima, and then this one, loop antenna design. High voltage. Okay, so I think I understand it. Basically, high amplitudes. It literally just says it right here. I'm gonna say I'm gonna ask I'm gonna send this to Ionel Dinu. Here's an AI overview. I'll just copy this. And then because I think Grok is like frozen. All right. So anyways, I think we solved it. So I think we got. I'm gonna go. I'll just all to my giant reply to him, and I'll say hi Dinu. Oh, hi, I know. I asked AI about the basically about the current. 1 second. Yeah, about the uniform current like everybody, you need to put words on these things. What are these called? Yeah, but a closed oscillating circuit does not radiate if the frequency in such a flows all in the same direction at the same time. Yeah, about the closed circuit. Uniform current setup. I think I get it. Basically yeah, so yeah, basically you need basically to get radiation you would need nodes, antinodes of electrogen built up along the side of the wire, along the side, yeah, surface of the wire. So think of it like as like lumps or whatever you need. I think that's what it is. Here's another response. I said here's another response here. It seems pretty sweet actually. Okay. Here's another response. AI response. Another AI response. Okay. Anyways, so I think we grasped that. I'm gonna continue reading on further. So now we have yeah. I'm now gonna fix up the setup here. Yeah, anyways, I'll have to do this more when I have some time. Okay, so he sent this one. Okay, I'm gonna keep reading this part here. He sent a whole bunch of stuff here. So I've sent you three screenshots which contain that, and yes, I read those over, and I think he sent three. Oh, those were before. So those are 3 screenshots. So thanks for notification about the type I've corrected. I sent you the three screenshots. Oh, this is a forward one. Okay, this is a forward one, and he included the book, the Fleming book right here. of Mumbo Jumbo's. Yes, that's Fleming 1906 book. And I said, thanks for explanation of the PDF. It makes sense. We'll dive into it again next Wednesday. Also, in your paper, you discuss light propagating in channels, which is very similar to this recent video based on a recent paper that I watched. This is from the light doesn't travel as it travels like this. If you put light, it goes into channels depending on the setup here. So here's a setup here.
During this video, now let's get back to our experiment. Now the key to making this work is to shine the laser pointer directly through the thin water film of the bubble. Now
Yes, so basically you have a thin water film of a bubble, and and I don't want to get a copyright from this guy. He always does that. So you just put a cup over this, you get a thin film, and then you shine the laser straight into it. And because that there isn't a perfect uniformity in the refractive index or density of the fluid, it actually goes into a channel like lightning.
Laser through.
So what happens is you're gonna
Shine the light in here.
Yeah, so
shine the light in. Okay, let's shine the light in here.
and yeah, so you shine. I'm muting because it has music in the background. To get yeah, so it does that. It has like little channels and stuff. So it's pretty amazing actually. Yeah, so I'm gonna go copy. Ignore this SI nonsense. Okay, so that's pretty amazing. All right, so that's that. And then I'm gonna go, that's this part right here. All right, so that's that part, and then keep reading this one right here, and then he says, and thanks for the link. It is interesting. I've uploaded a new version of the paper, and then he updated this stuff. Small improvements. Last updated. So April that last updated. February 6th. YouTube channel. I think he already had that one already. So let's fix up the updates. Okay, I'm just gonna fix up the updates and so on. Yeah, so let's go all the way back up here. So link to YouTube channel. I think he's already that's the right one. Ether science. Okay, this one's the correspondence between the kinds of ether flow and physical effects it produced can be summarized in the table below. Okay, this is the one. This is page 25 correspondence. Oh, this is 3.0. Okay, and then that's how does this look like? That's this part right here. Page 25. 3. Okay, so this one here, V general remarks. Let's go back here. I'm gonna power through general remark. Okay, this is this part right here. All right, yeah, so anyways, the correspondence between the kinds of ether flow and the physical effects it produces can be summarized in the table below. For more, see Ionel Dinu, Fundamentals of a Theory of Ether, Part 2. So he explains this in more detail in Part 2. So I'll leave that at that. All right, anyways, it's part 25. Inertia mass. The ether acts on the accelerating object with a force proportional to the accelerating object through the ether and displaced by the, it's Newton's 25 table, inertia mass. That's inertia and mass right here. What the, where did it go? That's table, inertia, mass. Yeah, table, inertia. Okay, this one here. Okay, that's the full text there. Okay, table, inertia, mass. That's this right here, this full thingy. Okay, inertia mass, whoops, what happened? Newton's second law, this part here. Okay, so inertia mass, the ether acts on the accelerating object with a force proportional to the acceleration of the object through the ether and the volume V displaced by the object in the ether. Volume there, yeah, so proportional, basically, yeah, basically mass is just the volume displaced by the ether. That is the mass. and inertia and all that, because you have to move through the ether. You're displacing. It's just like buoyancy. All right, so that's that. His empirical law: the distance at which signals are received increases at the square of the height of antenna, is proof of the statement. Page 27. Page 27. Double. Where's the what in the world? His empirical law. I'm just gonna go right here. Empirical law. Okay, there it is. Yeah, so his, where did it just go? Yes, his empirical law that the distance at which signals are received increases the square of the height of the antenna is proof of this statement. Okay, Wild Swigger, my brother said that the ether idea was debunked. Is it real still? No, obviously it's real. Yeah, so what is quantum fluid? Ask him ask him what is quantum fluid, or yeah, I'll ask him what is quantum fluid, what is waving in gravity, yeah, in EMF, yeah, in yeah, what is waving in matter, like, is there evidence that the theory exists? Asking what is what I'm trying to say is the mainstream it still talks about ether in different ways. Anyways, so what I'm trying to say is yeah, he wouldn't know. So then then what does he know though? No, it's the basically they just look back at the Michelson-Morley experiment, which is a very faulty experiment. Basically, there's no proof that the ether doesn't exist. There's and again, there's common sense says ether obviously exists. I'll show you this one here, fractal moment. Michelson-Morley. This is a good one. I'll have to do this one for another one. Michelson-Morley. But what I'm looking at is the Ionel Dinu specific theory of ether, not the other ones. Shocking revelation. So you can search Michelson in here. See this one. She has some good videos showing that the Michelson-Morley experiment is just it's a null experiment. It's the not it's not detecting anything it shouldn't detect. It's like just a whatever. But anyways, we have literally 9/11 towers turning to dust. We have ether tech going on. So it's like if there's advanced tech nobody's talking about, then basically science pretty much free and open. You can go and do whatever you want and find out. So I'm gonna put that right here. Michelson, Morley, and this as well. I might do that for maybe next week. I'll do what is the Michelson-Morley experiment. We'll go over that one next week. And then this week, yeah, and then behind the scenes, I'll try to finalize everything that I understand about this, and then read it out. Because initially I was going through this paper on these streams just so I can wrap my head around it, because I'm pretty sure this guy's onto something massive, absolutely massive. All right, get me close some stuff. So Grok is just wilding. Yeah, this trailer. Okay, that's this part here. Okay, yeah, anyways, let's see what else. Yeah, so I included this one here. William Priest, the closest of Marconi's collaborators in the practical demonstration of wireless transmissions, and most probably Marconi himself, believed without really knowing how exactly radio waves were emitted from their antennas that the pulsating voltage was indeed the cause of the emission of radio waves. So basically, the whole idea is that voltage is causing it, not the mainstream says current. It's the actual voltage, meaning when the current is lowest, basically when the highest pressure of the electricity, electrons, or electrogen, as Ionel Dinu would call it. Okay, page 27. William Priest. Okay, so I'm gonna go right here, and then I'll see if I can finish the whole thing. William Priest. Yeah. Okay, that's right here. William Priest. Yeah. So the closest William Priest, close of Marconi's collaborators in the practical demonstration of wireless transmissions, and most probably Marconi himself, believes that without really knowing how exactly radio waves were emitted from their antennas, that the pulsating voltage was indeed the cause of the emission of radio waves. And then the cool thing is, yeah, well, basically, the thing people don't realize is like you just have just like a piece of wire, and stick it to the ground, and then put current through it, and all of a sudden you get radio waves. like you can go and communicate across the galaxy and so on, just from like this little nonsense thingy. Yet mainstream, yeah, but there's no actual proper understanding of how in the world to do that. So anyways, I think he said some other. He said found an error. His empirical law. Okay, found another. This is correct. Okay, so it's empirical law. Okay, so his empirical law. Okay, so his empirical law that the distance at which signals are received increases the square root of the height of the antenna as proof of the statement. All right, so we have that. There's still an issue at page 127. Corrected again and change reference V5. So V5's changed his empirical. Okay, so I keep getting this wrong. But again. His empirical law. Okay, see what he says this time. So his empirical law, called Fleming-Marconi's law, that the distance at which signals are received increases the square of the height of the antenna as proof of the statement, and then he changes this V5 into this. This is going to be V5 is Fleming Hertzian Wave Wireless Telegraphy, Popular Science Monthly, June 1903. These guys referencing like 100 years papers from 100 years ago. Alright, so that's the actual V3 there. So thanks for updates. We'll power through this and I'll update our Hive article on Wednesday. So I sent him that. And I'm going to go and update now. So we have this and I'm going to go over some stuff. Now I'm going to try to finish it through. So, and then next week we'll go over Michelson-Morley experiment. Even if I've not done this one, I'll do this behind the scenes. But again, this stuff got me to spherical harmonics, which I'm like powering through. It's gonna be quite epic. I'll show you what I was working on. Here's my spherical harmonics video on Math 1. It's gonna be this is just my notes quickly. It's one of the most like complicated stuff. Like what in the world? Half these some of these are just I never covered before, so I'll have to cover later. But I'll be doing spherical harmonics because I think it's some pretty epic stuff there. Like it's just something about it. Which is like this is spherical harmonics. Like equations on a sphere and so on, and they all for some reason they match atomic orbitals and all that. So this is spherical harmonics, and they somehow match atomic orbitals and all this jazz. So it's gonna be quite interesting. So all these again be described mathematically, which is and then they somehow appear as the electron like probability distributions on a atom. So on hydrogen and all that. So that's gonna be quite cool. Yeah, so anyways, so hopefully you guys like the spherical harmonics video if you're a nerd or a math enthusiast. But that one's pretty cool. I definitely wrap your head around it's I'm trying to wrap my head around it, and I'll hopefully get that video up next week. It just takes yeah, it's gonna take a while. But anyways, okay, so now I've published I updated this one on the Hive blockchain, and I'm gonna read through. All right. All right. Yeah, let's go back here. So now I'm gonna try to power through the last bit of it, and then yeah, and we'll just go to the channel. So basically, I pretty much understand a lot of this. We have 40 minutes. I'm gonna see how much we can power through, just to give you the general idea, and then I'll be referencing this later. And also, he has a patent for anti-gravity theoretical device. So that's something I definitely want to try out. All right. So anyways, let's go back here. So. All right, so according to, yeah, basically you need alternating current. It needs to go forward and backwards. The actual electrons or electrogen needs to be actually turning direction. I mean, and needs to not turn direction. If you have a scenario where it's going forward and then all of a sudden goes back, it would stop and shake, etc. That created radio waves or something like that. I'm just gonna have to let's keep this in the back pocket of my head. And then we'll do that later. So anyways, emission radio antennas at right angles. So we have that over here. And now we'll go further. So anyways, below are the voltage and yeah, so yeah, let's go back here. So if you, just to recap quickly. So if you have an antenna, it's just a long like wire. The longer it is, the better the stuff is. just to recap on before. So the current, so when you have current going in here, it bunches up over here, and then the actual current is minimum at the tip, and the voltage is the highest. Yeah, the voltage is the highest over there, and then basically, basically you're gonna create areas of when it's the ether gets compressed and then expanded. It's compressed when it goes back here. You have the reverse setup there, where basically it's gonna turn out like this. So you have electrogen access, and then you have the this is compression, rarefaction. So it's gonna be a compression wave, and then the next cycle when it goes back and forward. So when all the electrons go in here, it bunches up. You have compression, and then when it goes all out of here, you have a giant void in the ether. That's the refraction. And it's basically he's saying that radio waves are electric waves, which are basically gravitational, electrogravitational waves, which is literally pulsating forward and backward of the ether. And that difference between these two, so the difference between these two is an actual gravitational field. Like that's what sensation of gravity. So there's no magnetic component in actual radio waves, unlike mainstream says that they're electromagnetic waves. So there's no magnetic component according to his theory, which I think is correct. So below are shown the voltage and current distribution for a half wavelength antenna, center fed, and its radiation pattern. All right, so here's the how the radiation pattern looks for this one here. So if you have current goes in and then up, and then so fundamentals of radio electronics. This is a current distribution. Yeah, so notice the current's always minimal at the end. And it's the highest over here. And then the distribution is going to go around like this. Radiation characteristic of a half-wave antenna. And basically, I think he was saying that so this is all, this stuff is not detected because this is near field stuff. This is the far field stuff. It pushes super far out there. And that's pretty much, what you have. It can be seen that there are two sets of waves generated in anti-phase by the voltage distribution along the two arms of the antenna. The two waves interfere and produce maximum radiation in a direction perpendicular to the antenna. Yeah, so it goes perpendicular in both directions, like that. It should be mentioned that in order to obtain the radiation pattern shown above, right, the waves generated by the two arms of the antenna should not be considered spherical and generated strictly from the tips of the antenna. Instead, the true shapes of the wavefronts should be considered, or else, if a spherical approximation is used, the center of the spherical wave should be one wavelength apart. So the center of the spherical wave. So it should be like basically wavelength across it. But anyways, there's more technical stuff. So the figure below shows the wavefronts of the radio waves produced by the pulsating electrogen along the half wavelength antenna. It can be seen that the intensity of the resulting wave is along the lines of radiation pattern shown below. So I think that's how he sets up here. So yeah, whenever you have a compression here on this, this is the electrogen going high up in here. You're gonna have the negative side here. Basically, the negative. I mean, the positive is when you have a deficit of electrogen. This is again, mainstream has a current in the opposite directions. So basically, it goes. You have current going in here. High electrons basically is negative, and then you have a deficit here. Then that's rarefaction. So compression, rarefaction, compression, rarefaction, and so on. And then and basically that's how it looks like over there. On the next page, I show approximately the correspondence between these wavefronts and those that exist in the present-day electromagnetic theory. The diagrams showing the wavefronts of this type of antenna were drawn for the first time by Hertz V11 and have been reproduced since then in books on wireless radio waves, antenna, and electromagnetic mechanism by Fleming and Mazzotto until the modern times by Krauss and Balance. And also what I want to do is quickly is this book right here. This is a pretty important book, so I'm gonna copy. I'm gonna actually copy my local one here. So share this. I'm gonna share this and put it in his actual link there, so that because I was trying to find it, I couldn't find it before. So no, this is actually so you can actually download it, apply, and copy this link. All right. All right, and I'm gonna go and V5. This is Fleming. I'm gonna sit down and power through for the last 30 minutes. V5. Let's refresh and then go there. V5. Okay, this is Fleming. And then PDF. I'll put a date. Local MES PDF. Okay, so this is just so you know it's from mine. Okay, so and then delete this tracking nonsense. All right. Yeah, and then I'll just update this one quickly and then just check it out. And we'll power through. Okay, V5, yeah, so it's a local MES PDF. Click it, see what happens. And yeah, I'm gonna sit down now. Okay, so there it is, and then you can download it and so on. Alright, lowering my chair, okay. So we're back on. And we got that. Let's just power through what else we have in here. I'm just gonna keep going and see. Okay, he has a whole bunch of other stuff there. Holy. Fleming. Oh, this is a 1903 one. Okay, I got it in the wrong thingy. It's 1903. No, that's V5, isn't it? V5? Fleming Hertzian. No, this is the wrong one. Okay, I got the wrong one. It's not V5. My bad. 1 second. I'll be done this quickly. Okay, it's 1906. Fleming, Principles of Teleography. This one here is, yeah, it's V8, okay. Principles of Electric Wave Theory. Yeah, so it has them all in here. So I'll just put a local MES PDF. Like that. Let's do this for all of them, maybe. Okay, yeah, I'll just leave it like that. Okay, anyways, I'll just leave it for that first one. I hate when it just, okay, 1906. Okay, there it is. Local MES PDF. Okay, and we are back. No, this is Fleming 3. Okay. Where in the world are we at right now? Okay, yeah, we went past here. Did we go through all this part here? Yeah, I think we already went through on this one before. Okay. Yeah, I'm just gonna do more high level stuff. I'll try to dive into the super details later because it's a bit above. The details are a bit above my head because I haven't done electronics like engineering before. So anyways, so on the next page, I show approximately the correspondence between these wavefronts and those that exist in the present-day electromagnetic theory. The diagrams showing the wavefronts of this type of antenna were drawn for the first time by Hertz V11 and have been reproduced since then on books on wireless radio waves antenna electromagnetism by Fleming Mazzotto until the modern times by Krauss Bollnitz. Right here. V13. Okay. So that diagram shown below is that from an animation that is also inspired from Hertz's original drawing on drawings and explanations. And this is how the mainstream draws these things, which again they don't actually have any like physical meaning or physical easy way to understand what in the world's going on here. Shown below, diagram shown below. Okay, it's animation. This is, I need to fix this up. Okay, this is a delete. All right, and I'm also considering doing this doing these maybe every other week, so I can 1 week I could prepare. So my next week I might not have it. I might do the week after, just so I can do my thing. Just so I can prepare. Just similar how I do the live streams every other week, just so I can get on this. Okay, I'm gonna go right here. Okay, so diagram below shown below is from an animation that is also inspired from the Hertz original drawing. So this is the mainstream one. He draws over it. So this is from Wikipedia. You can go here. I'll just do radio waves. Raise wiki. Yeah, so here's radio waves, or formerly called Hertzian waves, are a type of electromagnetic radiation with the lowest frequencies and the longest wavelengths in the electromagnetic spectrum. But anyways, here's an animation of a half wave dipole antenna radiating radio waves showing the electric field lines on. And so notice they only show the electric field lines. Well, then they're saying the magnetic is going to be perpendicular to that. The antenna is in the center. Yeah, so read the full thing. The antenna in the center is 2 vertical metal rods connected to a radio transmitter, not shown. The transmitter applies an alternating electric current to the rods, which charges them alternatively positive and negative. Loops of electric field leave the antenna and travel at the speed of light. These are the radio waves. In this animation, the action is shown slowed down tremendously. All right, this is slowed down. And basically, yeah, notice, so this basically they're saying that this is how the electric field looks like. Oh, I'll see there's a way to stop it. Yeah, so this is basically how it is. But then you have loops electric field. Like, the question is, what's an electric field? Why is there a loop like that? What does it actually mean? And notice how it's alternating inwards and outwards, inwards, outwards, inwards, outwards. So this is the part where, yeah, where I think the negative positive, it just means one's compression, one's refraction. So this is this part here. So here is his drawing. So the labels C, R, and G correspond to the zones of compression, refraction, and ether pressure gradient within the wave. And that ether pressure gradient, I think that's pretty much that's gravity. So G is for gravity. So C, H, R. So here's compression is when you have the negative. So negative is just ether compression. Positive is just ether rarefaction. In other words, deficit of electrogen or deficit of electrons. So electrons are here. When you have positive, it just means you have a lot of electrons. When you have I mean, when you have negative, you have a lot of electrons. When you have positive, it means you don't have much electrons. That's all it is. And this electrons compress the ether. So the general idea is yes, you have this compression, and notice how yeah, this radiates outwards like this. This is the so each time, so you have, at each compression, this is compression, there's a rarefaction wave. So it goes outwards like that, and then you're gonna have switch sides there. So this compression right here matches along this side. So this is the next one, and then each time it reverses. Then this one's gonna be on the top rarefaction. So notice this rarefaction is going this way, looping. And then compression is looping opposite way. Yeah, and then in between, now you have a pressure gradient of rarefaction, which is a low pressure, high pressure. So low pressure, high pressure. So you're gonna have gravitation going towards this empty void. So this is like basically the whole idea is, and which I think is the key to Hutchinson effect and all this, is that radio waves are electrogravitic. Like they actually have a gravitational component. And this is why mainstream never, yeah, they never come across it, and because they always think it's electromagnetic. So then they don't realize, okay, how is Hutchinson effect obtaining gravitational effects from radio waves, essentially radio waves and like static electricity? This is why. The reason I think fundamentally is this, is that this is basically after all the ether theory of ether, the streams I've been doing, this is pretty much what you have to drive home the point. Rarefaction, compression, and there's alternating, but then in between is that gravitational field. Like that's what affects it, and you can explain photoelectric effect with this as well, without needing to do photons and all that. So the labels C, R, and G correspond to the zones of compression, rarefaction, and ether. This is collar spin. Okay, I don't know what that means. Interesting. Is that what collar spin means? Anyways, this is collar spin. Okay, I don't know what in the world you just said. All right, please, is there something Mitch? This is called spin. Okay, so that's what spin is. No, I'm talking about there's no. Would that be what spin is in the electro? Yeah. No series of Wench. Okay, yes, basically this is called spin. Okay, yeah. Yeah. So basically, what I'm trying to say is like mainstream gives you terms, but they don't actually mean anything. It's like it's like they say electron has spin, but it doesn't actually spin. So like, well, why is calling it spin then? Below are screenshots from a very interesting video, V15, that proves the theory advanced here, namely that radio waves are emitted from the points where the amplitude of voltage oscillation is maximum. The antenna used in the experiment is a half wavelength antenna, and the emission of the radiation is corresponding to the voltage distribution and not the current distribution. Okay, so basically, because mainstream says current, he's saying it's voltage, and he's proving it right here along the antenna. Okay, so here's an interesting video. I'll play this video. So you have antenna right here. It's like a dipole. I think it would basically go negative, positive, negative, positive, but negative, positive. And then the current. Notice how this thing lights up at the source of highest voltage, not highest current. So it's not because these currents are moving. This is the highest movement here, but there's the lowest amount of electricity that's flowing through this this light bulb. So it goes to the end. Okay, so there, yeah, that's pretty fascinating stuff. So we just concluded that. And this radio waves properties, electromagnetic dipole antenna, Harvard Science Lecture. Let's play this demonstration. I might have to play this video as a experiment then. See the oh, and he's wearing a mask. Oh my goodness. So an HP model 3200 BVH oscillator and ENI model whatever broadband model F1000L NMR radio frequency broadband power amplifier provide a 300 megahertz signal to a half wave dipole antenna. The voltage variation along the length of the dipole transmitting antenna is made evident by touching one end of a 8-watt fluorescent lamp. A copper rod of the same length as the transmitting antenna is used to show a similar standing wave in voltage along it. Alright, a second receiver antenna with an incandescent bulb wired in the middle shows the polarization and the shape of the radiation pattern emitted by the transmitter. Finally, a loop antenna is used to show the polarization of the magnetic component of the electromagnetic wave. Okay, a whole bunch of
Here I have a 300 megahertz oscillator.
Okay, so that's the oscillator. Basically, it will change the frequency, or basically changes the sign of the current, positive, negative. In other words, yeah, which direction it's going, and so on. So the electrogen, basically vibrating it. So this guy's commenting. Okay, this guy's saying, is this the trailer? Okay, yeah. Finally, someone getting the word out that there were no quote Boeings. I don't want to get YouTube taken down. Not first tower, not Pentagon, not Shanksville, not second tower. Why not real? Because those towers had to come down that day for the insurance money, and it wasn't going to be left to chance. Not to mention 1,000 reasons why it was done. Yeah, but also they didn't like go down. They went up. Towers went up into dust, and so on. All right. Anyways, yeah. Okay, let's go right here. Play right here.
And a 100 watt radio frequency amplifier. It's going to be amplifying the output.
Okay, so this is just the signal going in, the frequency going basically positive, negative, and then or just going side to side, blah blah blah, and then this amplifies. It basically charges it up using whatever to make it higher power.
Output of our 300 megahertz oscillator, and oscillator, and a 100 watt radio frequency amplifier. It's going to be amplifying the output of our 300 megahertz oscillator and sending it to this dipole antenna to transmit radio waves. Let's turn it on and see what effect it has on this 8-watt, 1-foot fluorescent light bulb. If I bring the fluorescent light bulb near the end of the transmitting antenna, it lights up, even though it nor I is plugged into anything. If I slide it along the length of the dipole antenna, we notice that the intensity decreases and is a minimum at the middle of the dipole antenna, and then increases in intensity again as I go towards the outer edge of the other side. It's then dim once again, once I go toward the middle, and maximum on the ends. So this is evidence that there's standing waves that are set up on our dipole antenna with a maximum in potential or antinodes at the ends and a minimum in potential or a node in the middle. We can see a similar effect if I take a simple receiving piece of copper pipe as a receiving antenna. It's about 48 centimeters long. And if I hold it in the middle and bring the fluorescent bulb toward the end, it lights up even though it is not plugged into anything. And as I move the fluorescent bulb along the length, the amplitude is dimmest at the middle. And maximum at the ends.
Basically, that's the antenna, and this is the receiving antenna. It's just it all just sticks, like, or just the metal rod. So the metal rod there, powered through. Basically, you have the alternating current. Basically, it's just vibrating, literally changing the it's all it is. It's just vibrating the current, and then that amplifier does some magic to increase that. Basically, I think it vibrates and then increases the power or increases the strength of the vibration. And then it goes into here. So think of the electrogen across here, literally getting vibrating so much across it violently, and that's emitting this electrogravitational waves. And then from there, it also shakes inside these fluorescent stuff here, and that the light being emitted is then being shaken, and then which is near the tip. And those get and that shaking caused the ether to basically shake, and that's what you're seeing. You're literally seeing the ether based on these fluorescent light bulbs. I think they get like their individual whatever is vibrating rapidly. Anyways, I'm just wrapping my head around. Yeah, so I think I might do these streams every other week, just so I can prepare a lot better and get a whole lot of info and answers done.
As we saw for the transmitting antenna. Recognizing that the current is the maximum in the middle of our antenna.
Yeah, so current's maximum at the middle, and but the voltage is lowest, so hence why there's nothing there.
We're going to switch to one that has a single light bulb and use its brightness as a measure of intensity. As I move the receiving antenna closer to the transmitting antenna, the amplitude gets progressively stronger. We can also see that if I rotate the antenna relative to the orientation of the transmitting antenna, its intensity is 0 when the receiving antenna is perpendicular to the transmitting antenna.
Well, that's fascinating. Okay.
And maximum when it is parallel. We can also see that if I rotate the antenna or align the antenna along the axis of the receiving antenna, that the strength goes down. And if I rotate it so that it is perpendicular to the axis of the antenna, its intensity is 0. Lastly, if we look at the intensity of the antenna or the receiving antenna as I move in a cylinder around the transmitting antenna at a constant distance, we can see that the intensity stays constant. These help us visualize the radiation pattern off of the transmitting antenna. Here we have a different kind of antenna from the one that we saw earlier. Formerly, that long, straight conducting antenna was a dipole antenna that was sensitive to the electric field. This is a B-field antenna that is sensitive to the magnetic field. It has a loop to have currents induced within it, and a light bulb that is connected across a portion of the loop, and also 2 parallel plates that act as a tiny capacitor, which we can tune using this ruler to adjust the spacing between them. Let's take a look at the luminosity of our detector in several different orientations. We can see that with the loop parallel to the plane of the antenna, it has a high brightness, whereas if I rotate it by 90 degrees this way, it has a minimum brightness, and if I rotate it by 90 degrees once again, it also has a smaller brightness as compared to the original orientation. This tells us that the B field is maximum in this direction, that it is parallel to the normal of the plane of our of the B field loop antenna.
All right, that's fascinating stuff. I gotta wrap my head around. Okay, beneficent benefactors in the show. All right, epic stuff. How are you? All right, guys. Yeah, that's some fascinating stuff here. So yeah, I think I'll be doing this every other week, just so I can prepare better. So next week, yeah, so I'll do the week after. I'll do the same thing where I would set up the live stream time for the week after. So next in 2 weeks, topic I think will probably be Michelson-Morley experiment. What is that? And then yeah, and then so I can work on this behind the scenes and gives you some more time. I think it'll be a pretty good setup there. I'm gonna go quickly here. Okay, this one here, and then yeah, doing well. Yeah, I'm doing well as well. All right. That's great. Yeah, so you're gonna be on the show in next month, I think, or whenever we had that set up. I think I wrote it down before my Our cold fusion diode experiment was successful. Okay, amazing. Okay, I need to see that. I want to see this one here, Ben Factor. I'll have the featured guest. So yeah, just to let you know, we're you're still down for yeah, this is March 28th. So again, next Saturday is March 28th, Saturday. Epic stuff. I want to see that. Yeah, so March 28th, Saturday, 1 p.m. Pacific time. Get in there. Our battery should be fully conditioned with negative electricity by then. Okay, amazing stuff. I want to see this during that time. All right, now epic stuff. I want to try to see if I can finish this off. I think there's still a whole lot. Yeah, there's still a whole lot. I'm just gonna keep reading. There's stuff I don't if I haven't wrapped my head around, I'll save it for another time. But I will keep going. So yeah, so this is pretty fascinating. So basically, high voltage at the end, and that's lighting this up. Yeah. So anyways, so epic stuff. So Ben's gonna be on the show, and we're gonna do some anti-gravity. Free energy cold fusion experiments. Anyways, in addition to the radiation pattern, the directionality of transmitting and receiving antennas initially discovered by Marconi empirically proves to be extremely difficult to explain by the electromagnetic wave theory, since the electric and magnetic fields are not in such directions as to explain the production of electric currents in the receiving antenna. Yeah, that's interesting. The longitudinal wave theory explains it by, this is basically his setup, explains it by the wavefront sweeping along the antenna wire and moving the electrogen of the wire periodically along the antenna. See figure below. So Marconi's directive antenna for electric wave direction telegraphy, A, transmitting antenna, so you have the transmitting one, S, spark gap, so again, this is a whole reminds me of John Hodgson's setup there, A squared, receiving antenna, R, this is R is the ohmoscope. Is that what it's called? Ohmoscope. What in the world is an ohmoscope? Wiki. Otoscope or ohmoscope? What in the world is an ohmoscope? Direction of wind. No, that's this is like old language or whatever. Otoscope or ohmscope. What in the world is this? Ohmoscope. Okay, I'll just yes. Anyways, and wavefront. So basically, this is the antenna, the transmitting. A1, and then this A2, and basically the wavefronts. This is the longitudinal waves. It goes like this. In the other one, you have the electromagnetic. It goes up and down and side to side. How does that affect that? This is where when you make a claim like this, you gotta like draw it out exactly what is there, what's the mainstream claim. It proves to be extremely difficult to explain by the electromagnetic wave theory, since the electric and magnetic field are not in such directions as to explain the production of currents in the receiving. Yes, basically saying how can you explain currents? This one here, if it's longitudinal, it just the wavefront's just pushing the current. So you can literally have current. There's wire that's pushing it. It's sent. Epic stuff there. Yeah, so let's see that. I think you sent it over here. Yeah, I'll just power through. Why does it just not do stuff? Okay, power through. All right, Epic. Okay, so I'll keep an eye on that one. I'll add it to the notes and so on. Okay, I'm getting a bunch of stuff here. I just want to power through this last thingy here. Siri is useless most of the time. She doesn't have the functions I need. Okay. Yeah. So anyways, let's go back here. J. Fleming, the Principles of Electric Wave Telegraphy, 1906. So the conclusion of this discussion is that the ether movement in the radio wave is a to and fro motion, and since this to and fro motion was shown in this work to correspond to what we call electrostatic field, it is necessarily that it follows that radio waves and light are electric waves only, just as they were initially called by the discoverers before Hertz, by Hertz himself, and by other of his contemporaries. Heinrich Hertz electric waves being researches on the propagation of electric action with finite velocity through space. So electric waves have been produced before Hertz, 1888, by Elio Thomson, 1886, A.E. Dolbear, 1882, and most famously by David Edward Hughes. Not David A. Hughes at Distant Voyages. Yeah, so David Hughes is well, this is David Edward Hughes. History of wireless telegraphy, 19. Yeah, page this. You could have just put page in there. Anyways, so okay, the latter was also the inventor of the microphone. So the latter, this guy here, inventor of the microphone, he also had produced, so very early 1879, he produced radio waves, but he also invented the microphone, and his experiments with radio waves were witnessed, but sadly downplayed in importance by George Gabriel Stokes. E. Thomson and D.E. Hughes have stated that in rooms where the waves were created by powerful discharges, objects close to one another sparked as if they were charged with electricity, and the sparks ceased when the waves were stopped. Okay, so in rooms where the waves were created by powerful discharges, again, powerful discharge, you have that spark gap there. Is pretty interesting. So you have the spark gap antenna. I think that's basically, would that be the stuff that's sending radio waves? It's part I need to wrap my head around. I don't want to throw your presentation off, though. I might be in and out. Yeah, no worries. I'm almost done. I'll have like 7 minutes left. Yeah, it's short. Just an example how it's possible. Yeah. Because I'm done in like 7 minutes. Let's see if we can play it. Maybe. Let's see if it's too long or not. Yeah, let's play this right here. Okay, let's play it. No worries. You guys see what he's got? He's got this giant brain like Tesla and brain like rodent coil. Is this antenna picking up radiation energy? No input. There's no input. That'd be cool to get it put in a vacuum. Okay, so anyways, so you're collecting energy just by nothing. But did you initially put anything in it? So that's getting so you're getting a light bulb in there. So the question is, could it still be vibrating and whatnot? So and then how long does it go on? Because it could be according to the Ionel Dinu theory, all that stuff is vibrating. So basically, did you put anything in it? So that's the question. It could be kind of like a wheel when you spin it. You still have it spinning. Yes, it's a radiant that's wasted off the coil. Interesting. Okay, no, that's great stuff. We have 9 volts into okay, so into the primaries in there. So it might be collecting it like how those other stuff is. So that's pretty fascinating. This doesn't affect the power at all. Okay, and it just yeah, and it doesn't affect it. Okay, that's okay, so yeah, so that's something we need to wrap my head around. All right, epic stuff there. So we got some free energy, cold fusion, rodent coil, bend factor. Okay, yeah. So this is where we're when I do my streams every other week, I'll be able to dive my brain into it. Secondary pickup isn't interesting. Okay, yeah. So these are things I'll have a lot of questions on this. Yeah, so keep it up. It's taking over the game. All right, so we got bend factor taking over the game. I just want to finish the last part in here. This one needs to be the waves were stopped. Sparks ceased. Okay, this one. When I copied from the PDF, it all these errors. All right. Yeah, so we have bend factor taking over the game. And yeah, and you were powering that. So basically, what I like doing is like try to make it more and more extreme. See what you can come up with try to connect it to your computer. So the name of the game is get your phone charging on your phone. If you could charge your phone, you've done it all. Okay. So basically, he's saying here the latter was also the inventor of the microphone, and his experiments with radio waves were witnessed, but sadly downplayed in importance by George Gabriel Stokes. E. Thompson and D. E. Hughes have stated that in rooms where the waves were created by powerful discharges, objects close to one another sparked as if they were charged with electricity, and then sparks ceased when the waves were stopped. All right, yeah, that's interesting. So, so basically, when there's so in rooms where the waves were created by powerful discharges, objects close to one another sparked as if they were charged with electricity, and the sparks ceased when the waves were stopped. So that's interesting. So thus, radio waves and light are not magnetic, as can be understood from the also from the fact the to and fro motion. This is a typo there. To fro motion. To and. Yeah, I'll do this. Yeah, this is. I'll do another typo right here. Yeah, and I'll just do another one. And then as the email I was sending him. Okay, also there was a typo here. Missed the dash and to and fro. Thus radio waves and light are not magnetic. And then yeah, that's this one here, to and fro. I think that's to and fro. So I'm gonna go quickly check his paper. Yeah. Oh no, never mind. It is right. I just didn't. I deleted this by accident. Okay, so we remove that part. Yeah. So thus radio waves. Thus radio waves. Yeah. So I made a mistake. My bad. Okay. Edit. All right. Anyways, yeah. So I'll be doing this another time. Can you send me this document after the stream when you can get a second? Yeah, this document is it's right here. He let me post on the Hive blockchain. Like I highly recommend you wrap your head around this. This is why I've been doing this since December. All these ones. So this is the paper. That's the paper, and you can also open up the. Like he allowed me. So Ionel Dinu, he gave me permission to upload this on the Hive blockchain, and it's similar to what I've done with yours. When I uploaded your guide on the rodent coils. So and then you can see the full link here. Here's this PDF. You can download the full PDF, and so on. And then there's the full paper here. But he let me put on the Hive blockchain. So that's cool stuff of him. And then two. Yeah, so I highly recommend looking through this, wrapping your head around this. See what else we had. Yeah, but anyways, I think my okay, I'm gonna go over here. Yeah, anyways, we ended up over here. Wavelengths. Conclusion is to and fro. And yeah, and basically, I'm gonna read this. And then you're gonna basically once you grasp it, you realize okay, sound is literally just light is just ether sound. That's all it is. That's all it ever will be. It's just ether sound. Okay. And you could do very very similar setups over here. And this is just sound waves creating like gravitational setup there, like more macro stuff. Okay, I'm just gonna fix up these errors that I have a phenomenon similar to stationary waves, similar to this, and then I'm gonna head out, and then yeah, so I'll be back in 2 weeks. I'm gonna do every other week so I can have one week which is prepare. So I'll have the title and prepare. Yes, Tesla just said light is just sound waves in ether. Yeah, that's all it is. What I'm trying to so what that means also is that light is not electromagnetic. It's electrogravitational. And basically, electricity is the ether compression and rarefaction. And then the separation between the two, when you have a gradient, that's gravity. Like when you have a zone of high pressure and low pressure. And then magnetism is just rotation. So basically rotation of the ether. Yeah, so it's different modality, the same fundamental energy. Yeah, but it's the whole idea is just ether. And then mass and inertia is just the volume displaced of the ether. Yeah, so the whole part is magnetism is yeah, so light doesn't have a magnetic component, it doesn't have a rotational component. And so on, and also the other part, yeah. So let's see the phenomena. Okay, I fix these up, and then he goes through a lot of other stuff. The key one is showing the light goes into light goes through channels and so on. And he has a whole. It keeps going on and on. All right. Anyways, so and he described light being as channels, and then what you see as light is just an average of all of these like millions of times. Electricity, the compression refraction of the ether. I'll think about that for a while because that makes sense. Yeah, good stuff. Yeah, and you could explain you could explain action at a distance, basically, like things like photoelectric effect. How you can literally just vibrate electrons off metal surface, and how you can literally light up your light bulb just by going near an antenna. So it's like it just because it gets vibrating, like the vibration vibrates the fluorescent stuff inside, and the fluorescent the atoms just shake the light and I mean, it just vibrate and send the light out, and also. Vibration is, yeah, basically vibration, depending on the frequency, is what static electricity is and all that. So you can definitely see this paper. I've been going over it many times. So anyways, so next week, in 2 weeks, I'll go over the other stuff. Once I'm done fully this one, I'm gonna go. I think I'll. Yeah, I didn't. Actually, this one right here. I'm gonna go over the Michelson-Morley experiment, but then I'll also just finish off this as well. So I'll be adding these at the end of each one. And so on. I'll be trying to wrap my head around. Anyways, guys, that's all for today, guys. I'll continue on. So, anyways, Ionel Dinu, and he has a paper, and he has a patent for a hypothetical, a theoretical anti-gravity device. So he's got it all. Anyways, guys, that's all for today. Anyways, I just said there's no typo here. All right, I think I get asked about it. Okay, and then along the alright, that's pretty fascinating stuff. Okay, anyways, thanks for all your feedback. Yeah, anyways, thanks for your yeah. All right, that's all. Great. Okay, look forward to your next one. Yeah, for sure. Okay, send this. I'm just gonna send. No, I think I pretty much get it. Yeah, I'll just send this anyways. All right. I'm gonna close the setup right here. And also, here's the light and channels. This one, if you haven't seen this, light goes in channels in pretty much every medium because there's a lot of variations. This is light going through a film. Just a thin, like soap film. It's put on here. And the first person I ever heard about filaments, I mean, light going through channels was Ionel Dinu.
And what you're
So he puts
make this bubble film on top.
So that's bubble film, yeah, it's bubble film. And then you shine a laser light through the film of it. You get these, you literally get like lightning strikes. You get these fabrics, channel like stuff there. So it's pretty fascinating stuff there. Anyways, so that's all for today, guys. Thanks for joining, and yeah, thanks for joining. And have a great day. Great day. Yeah. So, anyways, I'll be back on these. I'll do this every other week just so I can focus and think longer. Alright, guys, that's all for today. And where's the only other person was in Odyssey. Okay, and adios. Ending stream 3, 2, 1. Cheers. I guys see you, Ben. Bye. All right.